Okay, so in this video I just want to give an example of how to make a frequency distribution given a set of data. And here what we have is this is the amount in dollars that 28 students spent on textbooks for a semester. And we can see that there are exactly 28 numbers here. So we're going to use 6 classes in our frequency distribution. The first thing you want to do is find out what the class width is. And for that, that's the class width is going to be the maximum minus the minimum, okay, divided by the number of classes. Okay. If we look at this, we can see that the largest value is 530. The smallest value is 47. We divide by 6 because that's the number of classes that will be given to us. And this is 80.5 on our calculator. And we always round up. Even if it was 80.1, you would round up to 81. Okay, so that we include all the values. Okay, now, so that's the class width. So that allows us to start with class limits. Okay, here are 6 classes. First, we start with the lower limits. The first lowest limit is going to be the minimum value, which is 47. And then we just add the class width to 47. And we get the next lowest limit, which is 128. We add 81 to that, we get 209. Then 290. Then 371. And then 452. Okay. So these are all the lower limits. And then the upper limits. Well, this upper limit here is going to be 1 less than the lower limit here, so this will be 127. Okay, 1 less than 209 is 208. 1 less than 290 is 289. 370, 451. And then for find the last one, we just notice all these gaps are 81, the class width. So we add 81 to 451, and we get 532. And that's important because now all the values are going to be fall in these one of these 6 categories. So for frequency, we just calculate how many of these values are between 47 and 127 inclusively, and you can do that with a tally if you want. You know, in this case, it turns out there were 4. Okay, so we put 4 here. In this class there are 7, in this class there are 7, in this class there are 3, this is 3, and this is 4. Okay. Now for the midpoint of the class is always going to be the lower limit plus the upper limit divided by 2. Okay, so that is the average of this. So, for example, 47 plus 127 divided by 2 is 87. Okay, so that's this. Then 128 plus 208 divided by 2 is 168. 209 plus 209 plus 289 divided by 2 is 249. And this one is 330. And this one is 411. And this one is 492. Okay. Note once again, you'll see that the class width, you can also add 81 to this, and to get this, add 81 here. All the gaps are equal to 81, the class width. The relative frequency is a fraction. There are 28 total values. So the relative frequency of this first class is 4 divided by 28, okay, which is, if we round to 3 decimal places, that should be enough, 0.143. Then the next one we have 7 divided by 28, is 0.25. Okay, this is also 0.25. Oh, this is 0.107. This is 0.107, and this is 0.143. Okay, you don't have to, in general, you don't have to include these fractions in here if you're going to do that. And then the cumulative frequency is just the running total of the frequencies. So here we start with 4. 4 plus 7 is 11. 11 plus 7 is 18. 18 plus 3 is 21. 21 plus 3 is 24. 24 plus 4 is 28. All right. So then there is the frequency distribution. Obviously, this last number here should always be equal to the total number of values you have. And then from here we can make a histogram. You can draw a histogram. Your calculator could do this too, but you can easily draw it yourself. Okay. We're going to plot our midpoints here. 87, 168. 249, 330, 411, and 492. Okay. Now I put a little squiggly here because this is just not drawn to scale, obviously, right? And then here we have, let's see, 1, 2, 3, 4, 5, 6, 7. I think 7 is our largest frequency. The first frequency is 4, so the first bar will go up to have a height 4. The next one has height 7. The next one has height 7. The next one has height 3. Height 3. And then height 4 again. So that's what the histogram looks like. You can see there's maybe slightly more values on the left than on the right. So if we wanted to say it was skewed at all, I mean, since there are seem to be fewer values on the right, we would say this is skewed right. If it's skewed at all. Okay. You could also say this is kind of evenly distributed, but if there's any skewness, remember skew rhymes with few, so that's why we say skewed right. And so this is our histogram.